Okay, students, so one question we will do in which the angle which is given here will not lie in the range of inverse function. Now I told you, right, if this angle does not lie in this inverse function, then what will happen? This will not be inverse of this one. Remember I said this angle must lie in the range of inverse, then only this will be identity. Tan inverse tan of this angle will give you directly this angle. But in this case, you can see, first thing, what is the range of tan inverse? The range of tan inverse is minus pi by 2 to pi by 2, right? It's like sine function only. The only thing is this will be open interval. Okay, so the angle which is there, it must lie in this range, then only this will be inverse function of this one. Now if this is inverse function of this, then only you can think that you have cancelled this and answer you will get this one, like identity we have done, remember? Okay, so in this case you will see 2 pi by 3. If you have confusion whether it will lie in this range or not, try to find out in terms of degree. 2 into 180 by 3, 60, so it will be how much? 120. So 120 degree, this is how much? Minus 90 to 90, right? So 120 does not lie in this range. So you can see this angle does not lie in this range. Now if it does not lie in this range, I cannot write directly the answer for this one, 2 pi by 3. Okay, because this is not inverse function of this one in this angle. Okay, so what we will do in such cases, if the angle does not lie, then what we will do? So in this kind of cases, this angle you have to lower it, that is you have to take smaller angle than this one which will lie in this one. Now which one you will take? So see what I will do with the one which I have studied in class 11, how to convert this angle into lower angle. Remember, if you have to find out tan of 270 or 275, suppose, then how we used to do? We don't find 275. What we used to do is we used to convert this 275 in terms of multiple of pi by 2, and then used to write down whatever comes out along with that pi by 2 small angle, that we used to find out, remember? So same thing we will do here also. Tan inverse this 2 pi by 3, which is equal to 120 degree, right, does not lie. What I will do, I will write in terms of pi by 2. Pi by 2 means what I can write? I will break this one into small angle. Pi 3, I have to get 2, right? So it will be pi by 3 here. Can I write in this form? Let me write open bracket only. Okay, so 2 pi by 3, can I write? We have already learned this one also, right? How to break into 3 into pi, 3 pi minus 1, this will give you 2 pi by 3. Same thing it will give. Now you can see this we have already studied, pi minus pi by 3. Now this pi by 3, what is the value? 180 by 3, that is 60 only. So 60 lies in this range. So I can write this one. First thing, see carefully, this we have done in class 11. 10 pi minus pi by pi means 2 into pi by 2, right? I told you multiple of pi by 2. So 2 into, this is what? 2 into pi by 2 minus pi by 3. Remember, if it is odd multiple of pi by 2, then trigonometry ratio will change, and if it is even, it will not change. So our aim was not to change this one, right? So that I can cancel this one. Actually not cancel, this is just a way of saying 10. Now see here, in which quadrant it will lie? Pi minus pi by 3. Pi is here, minus pi by 3 means in the second quadrant, right? So in the second quadrant, 10 will be positive or negative? 10 will be negative. A, S, T. 10 is positive only in third quadrant and first quadrant. So second quadrant it will be negative. So minus value will come out. Minus 10 of pi by 3. This is what we have done in class 11. So what my aim is here, whenever you have angle which does not lie in the range, make that angle lie in the range. How you will make? Break it. And I told you, right, in lower class only I told you, for 45 degree whatever is the value, if you rotate and come back here, for that also you will have same value. If you rotate and come back here, that also will have same value. So if it has same value, instead of finding this 360 plus 45, instead of finding that, simply find out 45 degree, that's it, right? So whatever 45 degree angle will give you value here, 360 plus 45 also will give you same value. right? Bigger angle will also give you same value. So if this bigger angle I can convert into smaller angle which give you same value, then I can do that, right? So 2 pi by 3 I have converted into pi by 3. So this pi by 3 and this 2 pi by 3, whatever value it will give, it will be always same. Okay, this will also give you negative of pi by 3 value. This also will give you negative of 3 pi by 3 value. Okay, so if you want, you can find out the angle also, it will be same here. Okay, so always we used to convert the bigger angle into smaller angle, right? Now you see here, now this angle lies in the range of this one, right? Now we can easily cancel. Now before that, first see here what form it is. Tan inverse minus of something, right? That is, I can say tan inverse minus x, right? Negative input, yes or no? So tan inverse negative input, what we used to, this is from the sine family, so minus will come out. Tan inverse tan of pi by 3. Now tan inverse and tan will get cancelled, you can say minus pi by 3 will be your answer. Okay, so what we have learned here is, if your angle does not lie in the range, make it lie in the range by breaking it and converting into smaller angle. Okay, and then you try to find out the value again. Okay, after that you can cancel that. Okay, so this is a different kind of question which was not there in your exercise, so I have thought that I better explain this also, because you will need this one in your next exercise. Okay, when you solve problem, you will get a situation where this angle will not lie in the range. So if it does not lie, you have to make it lie, otherwise you cannot write the value for tan inverse tan, whatever angle is the value for that one, you cannot write down directly the answer, you cannot cancel this, you can say. Okay, so if you cannot cancel this one, how you will solve this, right? Because we don't have rule to solve other than that one, right? So this will get cancelled and will get the value the moment you will make this angle lie in the range. Okay, so your first exercise is over. Right after this we will discuss some more identity formulas, and after that we will start exercise 2.2 also. Okay, now in your class 12 NCERT syllabus, your identity is very less, very few identity they have given. Okay, so we have to work with those identity only. Now you know, student, that when we know identity, solving problem become more easy, right? More simple. So since they have not given whatever identities were there for inverse, all inverse identity were not given, we will discuss only the one which is there in your NCERT book. Okay, so few identities are there. Okay, so these are the identities which you will need. Okay, so out of which the first one I have already derived it, I have already given the video yesterday. Okay, you can watch that one. Very simple proof. Sine inverse of x is equal to cosec inverse of 1 by x. The relation between sine and cosec. In normal trigonometric, sine x was what? 1 by cosec x, right? But in inverse, the inverse trigonometry function does not change, but its value, it will get reversed. Okay, x here 1 by x, the value will get reversed, not the function. Okay, so in this case, tan inverse x, it was tan x, it was 1 by cot x, right? But in this case, tan inverse x is equal to cot inverse 1 by x. Very easy to remember also. Okay, so derivation I have already shown you. The rest three types of identity you have, out of which in this case I have something to discuss later also. Okay, so I will discuss on this type of what formula I will discuss later also. Okay, and but the derivation of this one I will show you right now only, all this three. So first derivation we will do with this one. Okay, so what is the identity here? You can see it is sine inverse x plus cos inverse x is equal to pi by 2. Now it's always better to know the derivation. When you know the derivation, it becomes more easy to remember the identity. Okay, if you simply memorize the identity, there will be a chances that after few months or few days only you will forget the identity. But once you understand the derivation, it will always remain there. Okay, you can always remember this formulas. Okay, so see here how I will derive this one. So first thing, we'll try to understand what formula I will use to derive this. So see carefully. Sine inverse x plus cos inverse x is equal to pi by 2. Obviously, to derive this inverse trigonometry function, I will take help of normal trigonometry. All this identity which is there, I will take help of normal trigonometry function to derive all this. Okay, because I told you right last time also, to solve inverse trigonometry function you need to take help of normal trigonometry, because for inverse whatever rules we are deriving, we derive from the normal one only. Okay, so see here, first thing I have to get relation between sine and cos and pi by 2 also. Now you think, in your normal trigonometry, what was the relation between sine, cos and pi by 2? Okay, what is the relation between sine, cos and pi by 2 means 90 degree, right? So you might have remember this one, sine 90 minus theta, what it was? Cos theta, right? We have studied this one in class 10 also. Sine 90, that is pi by 2. Sine pi by 2 minus theta is equal to cos theta. Remember? Okay, so let me write down here only this one. Okay, we know sine pi by 2 minus okay, let me take theta only. Theta is equal to cos theta. Okay, now this one can I write like this? You have to make what? Sine inverse x. To make sine inverse x, what you have to have? Sine pi by 2 minus theta is equal to something x you have to have, right? If I write here x, will there be any problem? Obviously no. Sine inverse, to make sine inverse x, what I will do? Sine inverse, I will bring this side. It will become sine inverse, right? So see here, to make it sine inverse x and cos inverse x, see here, can I write sine pi by 2 minus theta equal to cos theta equal to x? Can I define like this? Now if I write like this, see what will happen. This one, can I write like this or not? Sine pi by 2 minus theta equal to x, and can I write cos theta is equal to x? This I can write. I am not violating any rule here, right? Now see from here what I can write. Pi by 2 minus theta equal to, derivation you don't need for your exam. Okay, this is for your understanding only. Sine inverse x. Can you see sine inverse x? I already got it. Here also, to get cos inverse x, what I will do? Theta I will write down as cos inverse x. Now see, in your proof I don't need theta, right? So what I will do? Can I add this two? Can you see, if you add this one and this one, what you will get? Sine inverse x plus cos inverse x on your right side, and theta will get cancelled, and pi by 2 you will get on the left side. So very simple proof, right? So I will add this two. So what you will get? Sine inverse x plus cos inverse x. Adding this, you mark it as 1. This you mark it as 2. You don't need the proof. Again I repeat, adding 1 and 2. Sine inverse x plus cos inverse x. What you will get? This plus this. Pi by 2 minus theta plus theta. So gone. So what you will get? Sine inverse x plus cos inverse x equal to pi by 2. So can you see how I have derived? I have seen, I need a relation between cos and sine in such a way that pi by 2 also will be there. So what relation I find out from the normal trigonometry is sine 90 minus theta is cos theta. That I have taken as x. Why? Because you see, sine inverse x, to make this you need to bring sine in the other side, right? So when you bring other side, x also must be there. So what I have taken, sine pi by 2 minus theta equal to cos theta equal to, I have taken x. Okay, some value. Now sine I can bring this side, so it will become sine inverse x. Cos also I can bring this side, it will become cos inverse. So separately I have written this one, and then I have added both, because addition you need, right? So that's why sine inverse x plus cos inverse x equal to pi by 2. So this become your formula. So it is an identity. Sine inverse, don't get confused, this is not square. Some student, what they used to do is, they used to remember like this. In your normal trigonometry, sine square theta plus cos square theta is equal to 1 it was, right? They used to remember something like this only. This one also, they used to think cos sine inverse square here also square equal to pi by 2. Not like that. This is sine inverse x, no square, plus cos inverse x equal to pi by 2. Same way tan and cot are related, right? In 90 minus theta, what I can write? Tan 90 minus theta equal to cot theta. Then sec 90 minus theta equal to cosec theta. So those also if you use, you will get tan inverse x plus cot inverse x, cot inverse x equal to pi by 2. Then sec inverse x plus cosec inverse x, you will get pi by 2. So these are the identity, these three identity you can derive in that way. Okay, very simple. So next derivation is also exactly same. See here how I will derive this one. So try to learn all this derivation. This will help you solving question also. Exactly same way we will solve question as well. Okay, so see here, tan inverse x plus tan inverse y is equal to tan inverse x plus y 1 plus xy. Now the derivation which we have done here, this sine inverse x plus cos inverse x is equal to pi by 2 is not for all value of x, it is for some value only. This must lie within some range. Okay, so right now you don't need to concentrate on that one because your NCERT book also said that no need to focus on this value. What value it will be pi by 2. In your syllabus they will give you the value which will lie within the range of this one. Okay, so together what range it will be you don't have to learn right now. Okay, so you don't have to concentrate on the value of x right now. Whenever you see something like this, you can always put pi by 2 because they will give you value within the range only. Okay, so I will show you in your book also it is written like that. Okay, no need to concentrate much on this values right now, but to make you understand I am telling you not for all value this identity is valid. Okay, not for all value, for some value of x only this identity is valid, because I told you, right, inverse exists for some value of codomain only. Okay, so this time see here, tan inverse x plus tan inverse y equal to tan inverse of x plus y 1 plus xy. So see here how we will derive this. Now see here properly, x plus y by 1 plus xy. This, does it look like any formula in normal trigonometry? Obviously yes. This was what? Remember, tan a plus b. What was the formula for tan a plus b? Tan a plus tan b by 1 minus tan a tan b. This is not plus, sorry, minus in the formula also. Okay, tan a tan b. Can you see it's like a formula only? Tan a plus tan b 1 minus tan a tan b. In place of tan a what it is? X. In place of tan b y. 1 minus in place of x tan a, in place of y tan b. Something like that, right? So this derivation also they have done from this formula only. Okay, so see how we will derive. So I told you, right, this derivation which you have here, we used to derive this one from the normal trigonometric function also only. Okay, so see here, what was the formula? Tan a plus b is equal to tan a plus whatever is the sign here in the numerator, always same. Tan a plus tan b, in the denominator sign change, 1 minus tan a tan b. So this was the formula, right? Now see, this formula I have to convert into inverse, everything inverse. Can you see? Tan inverse, tan inverse, tan inverse. To make this an inverse, what I will do? So see, to make this inverse tan a, you want to make it inverse, what you have to have? Tan a is equal to something you have to have here, right? Yes or no? So let me define this one as x. Okay, because see in your formula in place of tan a, x is there, right? So I am taking tan a equal to x, suppose, let, and in place of tan b you can see it was y, right? Tan b is equal to y. Okay, now see here, I will derive this one. Tan, can I bring this side? If I bring here, what you will get? A is equal to tan inverse x. What is your b? B is equal to tan inverse y. Right? Now this a b, if I put here, what you will get? See here. This is your 1, suppose. Okay. And so this formula I'm going to use to derive this formula, right, inverse formula. Now everything I want to convert into tan inverse here. The moment you will convert everything here into tan inverse, it will become this one. So see here, so to convert into tan inverse, what I have done, to make this tan inverse, you have to bring in the other side, right? Now y and I can bring when you have equation like this. So I have taken this one as x. Why? You can see this formula is exactly same like this one. In place of tan a only x is there. So that's why tan a I have taken as ax, tan b y. Okay. So from this tan I have brought this side, tan inverse x, it become tan inverse y. So I got it right. Now see these things I will put it here. So what you will get, tan a 1 implies you can write tan a plus b is equal to tan a. In place of a, what I can write, in place of a I can write tan inverse x, plus in place of b, what I can write, tan inverse b. Okay, sorry, tan inverse y. In place of b, tan inverse y, by 1 minus tan inverse, in place of a, tan inverse x, in place of b, tan b, in place of b, tan inverse y. Okay, tan inverse y. So tan get cancelled. This one what you will get, x plus here y by 1 minus tan gone, x, tan gone, y. So see, I got this one right. Now what I said, everything you have to convert into tan inverse. Now this I can easily convert into tan inverse, right? Just bring that side. So what you will get, a plus b is equal to tan inverse x plus y by 1 minus xy. So this side already you got tan inverse, right? Now see this one, ab, what I can put in place of ab, in place of a, tan inverse x, in place of b, tan inverse y is equal to tan inverse x plus y by 1 minus xy. So this is your formula. Now derivation, why I am showing is, if you suppose forgot the formula, you can also derive yourself. And moreover, when you practice derivation, it's much more easier to remember the formula. Otherwise, most of you will keep on getting confused when you solve exercise. Okay. So tan inverse x plus tan inverse y is always equal to tan inverse x plus y by 1 minus xy. So this become your formula. Same way, if you take minus here, this will become minus, this will become plus. Same way you can derive this formula. Now this also define for some value of x and y only. Okay, so that I will discuss. For this one I have to discuss little bit later. Okay, so when we will do exercise, then only we will discuss little bit on that again. Okay, for the time being, you remember this formula. So the last identity, so this is the last identity for you. After this we will start the exercise 2.2. we don't need any more identity other than this. Okay, so very few identity this year. Okay, so see, derivation of this one is also exactly same. So basically what we are doing, when we derive inverse function, what we are trying to do is, in the derivation you just see, in the formula you just see the formula looks like which formula in normal trigonometry function. You just find out that, and from there only you derive it. Okay, very simple. Now why I am saying this, now see, normal trigonometry formula you already know, right? In class 11 we have done many formulas. So if you know that, remembering this one will be very easy. You try to compare with that and try to remember this formula, inverse formula. It will become more easy. Okay, and if you know derivation also, then it's much better. Okay, so you can see in this case 2 tan inverse x is equal to what? This is twice the, this is what? Angle, right? Tan inverse x is what? It's nothing but angle, twice of theta. Remember double angle formula we have done in class 11. So that also very few we will do here. Okay, so see here, twice tan inverse x is equal to what? Sine inverse 2x by 1 plus x square. Do it look like any formula here? Yes. Which formula it look like? 2 of, in place of x, some trigonometry value, right? 1 plus some trigonometric value, and which square? So what trigonometry value? And you can see it is what? Sine inverse. Remember, sine twice theta. What was the formula? Twice tan theta by tan 1 plus tan square theta. This formula was there in normal trigonometry function. And this one, cos inverse 1 minus x square. This also, remember cos 2 theta in terms of tan, you had this formula, tan square theta by 1 plus tan square theta. Cos 2 theta, cos of double angle, this was the formula in terms of tan, cos of double angle, sine of double angle in terms of tan, and for tan also you had tan of double angle, twice angle, you had twice. It's exactly same like this one, remember, tan theta, only the difference is it was minus in the denominator. Okay, so from this 3 formula I will derive this 3. 2 tan inverse x is equal to sine inverse of this one, cos inverse of this, tan inverse of this. So can you see in your right side all are tan, so in your left side you can see sine, cos and tan. So this tan inverse I will convert into sine inverse, cos inverse and tan inverse. Okay, so everything I will make in terms of inverse here. So after that you will see this formula will be derived automatically. So first let's derive this one, the first portion, this is equal to this. So for that, this one. So you can see twice of tan theta 1 plus tan square theta. Twice of tan theta 1 plus tan square theta means what? Tan theta we have to let it as, let tan theta is equal to x. We will let this one. Okay. So theta is equal to what? Tan inverse x. Okay. Now see how we will derive. Your formula was what? Normal trigonometry function formula was twice theta is equal to 2 tan theta by 1 plus tan square theta. So this is your 1. So in your normal trigonometry I will put this one. Okay, so what will happen? 1 implies, same like previous one I'm doing, sine twice theta is equal to 2 tan, in place of theta what I can write? I am trying to convert everything in terms of inverse now. 1 plus tan square theta, in place of theta what I can write? Tan inverse x. Okay, which implies sine 2 theta is equal to this 10 will get cancelled. What you will get? 2x 1 plus. Now see here, this one what it looks like. Remember tan square theta, what you can write? Can I write tan theta whole square? In normal trigonometry you can bring the square outside, right? So this is what? Normal trigonometry only, right? Tan square, this is your theta, angle or not? Yes, tan square theta. So can I write this one like this? Tan theta whole square. Since you are doing for the first time, I'm writing this way. Okay, this one will cancel. Don't cancel actually. 1 plus x square sine 2 theta. Now sine, bring that side, sine inverse, this one you will get it. Sine inverse 2x, you will get it. In place of theta put it tan inverse, so you will get 2 tan inverse x is equal to sine inverse 2x plus 1 plus x square. Okay, so same way here also you put it, in place of theta you put tan inverse, you will get 1 minus x square 1 plus x square, cos bring this side, so you will get cos inverse 1 minus x square plus x square. In place of theta tan inverse you put it. Same with here also. In place of theta you put tan inverse x, so you will get 2x, tan will get cancelled, right? In place of theta you put tan inverse, you will get x square here, 1 minus x square. So tan bring this side, you will get tan inverse 2x 1 minus x square, and in place of theta put tan inverse, so you will get this identity. So these are the identities you need to remember, okay, to solve exercise 2.2.